All right, section 4.2 is translations of sine and cosine. So if we are graphing y equals c plus a sine of b times x minus d, or the cosine one, we are going to find an interval whose length is 1 period, 2 pi over b, by solving this three-part inequality. Now, when you're doing this, it doesn't matter if the b is factored out or if this b is multiplied through. You're still going to get the same result. This is going to tell you your new start and ending x values. So it's not always going to start at 0 and end at that 2 pi over b. Now it could change. We're still going to divide that interval up to have 5 key x values. And then we want to think about the original function's y value pattern. So for that sine, it starts at 0, ends at 0, halfway in between is 0, then that 1, -1. And then for the cosine, starts at 1, ends at 1, halfway in between -1. Other two values are 0. So thinking about those patterns. And then we want to apply these in order. If there's an amplitude change, we take care of that first. X-axis reflection, and then a vertical shift up or down. Those all affect the y values. We want to plot the points that we find in step 3 and draw over additional periods as needed. So the graph of a function, f of x minus d, is translated horizontally compared to the graph of f of x. It's going to be translated right if d is greater than 0, and translated left if d is less than 0. So we want to graph y equals sine of x minus pi over 3 over 1 period. So we start by solving that inequality. Add pi over 3 to everything. So now we're going from pi over 3 and ending at 7 pi over 3. So these are going to be your new start and end values. And whatever number is over here, that's a positive pi over 3. So our graph has been shifted right pi over 3 units. So whatever this is tells you how far left or right it is moved. If it's negative, it moved left. If it's positive, it moved right. Period is 2 pi over b, which is just 2 pi. B is the number in front of x. Okay, 7/3 plus 1/3 divided by 2. It's going to give you 4 pi over 3. Halfway in between these two, it's going to give you 5 pi over 6, and you'll get 11 pi over 6 for halfway in between these two. Okay, sine starts at 0, ends at 0, halfway in between is 0, and the amplitude is just 1. So 1 and -1. Highest denominator is 6, so count by pi over 6. Okay, 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 pi over 6 is 7 pi over 3. I'm just going to label the key points I need. See, 4 pi over 3. Okay, so we have pi over 3, 0. 5 pi over 6 is at 1. 4 pi over 3, 0. -1, 0. So there's that graph over one period. Okay, this one should have went to this point here. So like that instead of this line right there. Second example is graph y equals 3 cosine of x plus pi over 4. So we do 0, x plus pi over 4, and 2 pi. Subtract pi over 4 from everything. 2 minus a fourth is going to be 7 pi over 4. Again, this is going to tell you how far it shifted. So this is went left pi over 4 units. Our amplitude is 3 because of the number in front of cosine. Period 2 pi over b, which is just 2 pi. So we're starting at negative pi over 4, ending at 7 pi over 4. Halfway in between is 3 pi over 4. We'll have pi over 4 and 5 pi over 4. So again, to get the middle point, you add the beginning and end, divide by 2 to get the midpoint. To get the first quarter point, you add these two, divide by 2 to get that answer. Add these two, divide by 2 to get that. Okay, cosine starts at A, just 3, ends at A, halfway in between negative A and then 0. We're just doing one period. Okay, negative pi over 4, positive 3. Pi over 4, 0. 3 pi over 4, negative 3. 5 pi over 4, 0. 7 pi over 4. Okay, next example. Graph y equals negative 2 cosine of 3x plus pi over 2 periods. So we do that whole argument between 0 and 2 pi. Subtract pi. Divide by 3. So this tells you we went left pi over 3 units. Amplitude is 2. Periods 2 pi over 3. And we have a reflect over x because of the negative. So negative pi over 3 and at positive pi over 3. Halfway in between those is just 0. Negative pi over 6, pi over 6. Highest denominator 6, so we're going to count by pi over 6. Okay, cosine starts at A, which would be 2, but it's been reflected, so negative 2. Ends at A, but it's been reflected, so that's negative 2. This is going to be positive 2, and these are still 0. Negative pi over 6, negative 2 pi over 6, it's negative pi over 3. Negative pi over 3, negative 2, 0, 2, 0, negative 2. Then it's going to repeat. So that would be 2 periods. Okay, from negative pi over 3 to pi over 3, that's the points we found. And I know they're all 5 points. So then we just start here and repeat again. That's the second period. You could also go this direction and have another. We could have also done this. And that would be a third period. Or you could have had the 2 periods here or the 2 periods here. It doesn't matter. Okay, now we have vertical translations that we're going to mix in. So that's um, going to change your x-intercepts being on the x-axis. It's going to be shifted up or down. So if we have c plus your function, it's translated vertically compared to f of x. And it's going to be up c units if c is greater than 0, and down absolute value of c units if c is less than 0. So we have graph y equals 3 minus 2 cosine 3x over 2 periods. So we still do that as 0. It's going to be 3x and 2 pi. So we're going from 0 to 2 pi over 3. Your period is 2 pi over 3. Your amplitude is 2. It's reflected over x. And now we have up 3 units. Okay, starting at 0, ending at 2 pi over 3. Halfway in between those, so 2 pi over 3 divided by 2 is pi over 3. Halfway in between 0 and pi over 3 is pi over 6. And halfway in between here is pi over 2. Okay, cosine starts at a, which is 2, but has been reflected, so negative 2. And then it's been shifted up 3. So negative 2 plus 3 is 1. So starts at 1, ends at 1. Here would have been a negative 2, but it's been reflected, so it's positive 2 plus that vertical shift up 3 is 5. These 2 points would have been zeros, but we were shifted up 3. So 3 and 3. So that vertical shift, you can think as your new x-axis. So wherever it would have been 0 is that shift up or down. And we're going to count by pi over 6, because my highest denominator is 6. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. One, two, three, four, five. And then the opposite direction, because we need two periods. So we're at 0, 1, pi over 6, 3, pi over 3, 5, 3, and 1. And the other direction, so again, think of that 3 as your new x-axis, and your amplitude should be 2. So from that x-axis, it should go up 2 and down 2. Should be the highest and lowest it goes for amplitude. Okay, last example. Graph y equals -1 plus 2 sine of 4x plus pi over 2 periods. So we start by that 0, 4x plus pi, and 2 pi. So we're going to have negative pi and pi. Divide by 4. Negative pi over 4, x positive pi over 4. So my graph has been shifted left pi over 4 units. My amplitude is 2. Period is 2 pi over b, which is pi over 2. Vertical shift down 1. So we start at negative pi over 4 and at positive pi over 4. Halfway in between would be 0. We'll have negative pi over 8, positive pi over 8. Okay, sine starts at 0, but it's been shifted down 1. Ends at 0, but it's been shifted down 1. Halfway in between is 0, but it's been shifted down 1. So again, that shift is like your new x-axis. Where these were zeros, it's now that shift down 1. This would be at A, so positive 2, but it's been shifted down 1, so it's 1. This would have been at negative 2, shifted down 1, which would make it negative 3. And highest denominator is 8, so count by pi over 8. Okay, we have negative pi over 4, negative 1, negative pi over 8, 1, 0, negative 1, pi over 8, negative 3, and over an additional period would be like that. Again, this is like your new x-axis. That is all for section 4.2.